Hey, here is warm-up number 29. I've got a function here and asked how many zeros are there. Well, the zeros is going to be the same as the degree of the function. So this is going to be a third degree function. That means there are 3 zeros. That's the fundamental theorem of algebra tells me that. Okay? And then we're going to list the possible rational zeros. So I'm not going to list all of the possible zeros. I'm going to list the possible rational zeros using the rational root theorem, which means I'm going to take the factors of this over of the last term of the constant term over the factors of the leading coefficient. So my leading coefficient here is 1. Okay, so I'm going to do the factors of 4 over the factors of 1. Okay, so the factors of 4, I'm thinking all of the integers that go into 4. 1 goes into 4, 2 goes into 4, and 4 goes into 4. But also negative 1 goes into 4, and negative 2 and negative 4. So the negative versions of these go in as well. So I'm going to put a plus or minus in front of each one of these, okay? And then things that go into 1, only 1 and negative 1. So these are my possible rational roots, okay? So since I just have a 1 on the bottom, or a negative 1, if I took any of these pairs, we'd be dividing by 1 or negative 1, which really means my possible rational roots are the numbers 1, 2, and 4, both positive and negative, okay? It doesn't mean that those are all going to be roots, but if there are any rational roots, they are in this list, definitely, okay? So now what I'm going to do is attempt to factor this. And the first thing I might do factoring this, since I see I have 4 terms, is I would try to put this into groups. Because it's possible I could factor this by grouping. And let's see, I can factor x squared out of that first group. And I can factor 2 out of the second group. But I don't have the matching pieces that I need, so that's a dead end. Okay, so factoring by grouping is not going to work here. So what I want to do is use these possible rational roots and see if I can figure out if one of these 6 options is actually a rational root. If I get a rational 0, then I can factor down my original function and work from there. Okay. So one way to do this would just be to try synthetic division. Try all 6 options. It wouldn't take me that long. But just to save some time, what I'm going to do instead is graph this function on my calculator. So I've got something else in there now. But I hit the Y button to get to this screen. Okay, and I'm going to input x to the third plus 3x squared plus 6x plus 4. Oops, and I just noticed that happens sometimes. I wasn't looking at my screen. On this particular calculator, once I put an x to the third, I have to scroll to the right to get out of the exponent. Some of the calculators, you have to do that, and some you don't. 6 plus 4. Okay, got it in there now. I'm going to hit the graph button, okay, to get a look. And really what I'm looking for is I was thinking 1, 2, or 4, positive or negative. So I'm looking for places where my function is going to cross the x-axis. And hopefully I can find one of these numbers on there. And it looks to me like negative 1. So I'm thinking negative 1? That seems like that could be a root. This is a guess. X could equal negative 1. So if x does equal negative 1, then I should be able to factor out x plus 1 as a factor, okay? So I'm going to use synthetic division on my original function here. So I'm pulling out the factors 1, or the coefficients 1, 3, 6, and 4. There's no missing terms there. Okay, and if my guess is correct here, and you know, I don't know for sure just looking at this, because this could cross at negative 0.99 or something like that. I don't know, right? But let's see if this is really a rational root. if it is, I'll get a 0 remainder. It'll mean that my factor will go in evenly. So let's pull down that 1, then I'm multiplying by -1, adding here, then multiplying, adding, multiplying, and sure enough, that one did work. Okay, so now what I can say, if I take my original function, I've factored out, I know one of the factors, since x equals -1, that means x plus 1 is one of the factors, right? If you think about the 0 product property, if this was set equal to 0, x would equal -1, right? Now, the part that is left over once I've factored out the x plus 1 is this polynomial. So I just have to rebuild that. There's no remainder. So this would be a 4, this would be a 2x, this would be an x squared. Okay? And so now I've got it down to this. That's good. I've done some factoring. I want to see if I can factor the trinomial further. So let's just set up a little diamond problem. I'm looking for two numbers that add to 2 and multiply to 4. And I want to use integers. But there's nothing that works here because my only options are 1 and 4, positive or negative. I mean, I could do the double positive version. Those don't work. Or 2 and 2, but those don't add up to 2 either. So this is a dead end. And that means that this is completely factored. So I've got that completely factored there. Okay, and then next up, I'm going to find all of the zeros. So I'm going to use this factoring that I did. Okay, so to find zeros, I'm going to plug in 0 for f of x. Okay, and so I've got if x plus 1 equals 0, then x equals -1. That one I already knew about, right? That was my guess from back here that I verified. But I should have 3 total zeros. Now, when I looked at the graph, it looked like it only crossed the x-axis once, and it did. But I've still got 2 more zeros, so I'm guessing that these are going to be imaginary zeros. But let's see. Let's see what happens when we set this equal to 0. Okay, now I can't factor it further. It would be nice if I could, but I can't. But I can still solve it, and I've got 2 options left, quadratic formula or completing the square. I'm going to complete the square there, but if you prefer quadratic formula, you'll get the same result. So I'm going to look for the mystery number, which is not 4. So I'm going to move that 4 over to the other side of the equation to make room for my mystery number here. So subtracting 4, and then whatever I add to the left side of the function, the equation, I'm going to add to the right side. Okay? All right. Let's find our mystery number. So remember this mystery number on both sides. I'm going to use a little formula, b over 2 squared. My b here is 2. So I've got 1 squared, which is 1. So the mystery number is 1. Okay? The left side, I want to factor this. It should factor into something squared, something times itself, some binomial times itself. So let's see if that happens. I'm going to put a 2 on top, 1 on bottom, and this is going to be double 1s. Okay, so that means this is going to work out. This factors into x plus 1 squared. On the left side, I've got -4 plus 1 is -3. And now I can square both sides of the equation. So when you do that, don't forget the plus and minus. Plus or minus. There's a positive and a negative root. If you don't put that in, then we've only got 1 0 over here. But we know we're going to have 3 zeros. So there's going to be 1 here, and there's going to be 2 here because I have the plus minus. Okay? Let's isolate the x. I'm going to subtract 1 from both sides. I'm going to slip that in front of the root. And then I'm going to rewrite this as I root 3 because it's the square root of -1 times the square root of 3. So just as I had predicted, I've got 2 imaginary roots here. So if you count them up, got 1, 2, 3, right? 3 of them, just like I thought I would on the first problem. Okay, that's it for today. See you next time.